This project is the chuck jaw. The chuck jaw has first an outline to extrude, and then a cut on the bottom, two holes, but also these cuts are curved. That's due to its inclusion in an assembly of a chuck. The most important aspect of a chuck is the axis that it's going to rotate about. That's shown in the diagram by the axis on the far right that has a 4.5-inch radius to it. So that's going to be the trickiest part of what we need to do. So we will go to a new part and make sure that it is in inches. So we'll go to inch pound second, and we'll make sure that we change it to 3 decimal places. So the first thing we're going to do is make the overall block outline. So going to extrude on the front plane, and notice that it is also symmetric, so we're going to use a mid-plane extrusion. I'm going to keep the origin in the lower left. And go up here, over. I'm going to make an overall block so it's easier to see how the cut happens. Then this just needs to be dimensioned. Give the overall bottom, overall side. That looks 30. And height given is 62. This detail here. I'm going to put 0.75. Oops. Actually has a tolerance on it to be just under 0.75, so 748. And this is well, now where is this located? Now if we can drag this back and forth, we're going to need to make sure that we have that dimension. That's 1.5 from the right side. And our outline is complete. Again, it's a symmetric part, so we want to use, instead of blind, a mid-plane extrusion. That allows us to extrude on either side of the intended plane. And the overall depth is 1.7. And there's our first block. Next thing to do is to cut the slot in the bottom. Extruded cut off of that plane. Look at it head on. I'm going to make sure it's symmetric by putting in a center line. A line to the origin right here. So now, after escaping from that, hold the control key down, hold both sides, hold the center line, click on symmetric, and now these lines will always be symmetric about the center. I just need to dimension. 7.2. And then a vertical dimension, actually from the top of the cut to the edge, shown there, 120 thousandths. That does it there, and we're going to go all the way through. And there's our slot. Now the next couple of features are going to be used to set up the cut that has the curves in it. The very top of the diagram, you see that there is a 1.75 inch dimension from this face over to a point right about here. From there, we have a 4.5 inch radius to some axis out in the middle of nowhere, but that axis is on the middle plane. Again, symmetry is very important. So what I'm going to do is I'm going to just create a sketch. You go in sketch mode, put this plane, and I'm going to simply make a point. I'm going to put this point right here, on that edge, and then I'm going to dimension. From that edge to here, 1.75. Then I'm going to make another point, and we'll put that point out in space over here. I'm going to hold the control key down, that point selected, and I want to make sure that that point is aligned with the front plane. Escape out of point making. There, I'm going to select the point, align it with the front plane, make sure it's coincident, so now I know it's always going to be on that middle plane there. And now I'm going to dimension that 4.5 inch distance. Now notice that any of these dimensions, if they're at a slant, it can be horizontally defined. If you get it to a certain point, vertically defined on the slant, or if you get it at the right spot, vertically defined. We want it on the slant. Now it goes off the page. There it is. So now we have our point that we need to make several of these cuts around. Now this axis of rotation in a lathe or a drill or whatever, something that requires a chuck to keep it on the axis. That axis is so important, I'm going to create a brand new axis right here so that it can be used for whoever is going to assemble these parts. I'm going to go reference geometry, axis, and I need to select various features, whether it's in sketches or edges or whatever, and to find this, I'm going to make sure it's in the front plane. Now it doesn't know exactly where it is. It could be anywhere in that front plane. It's chosen to be perpendicular to the plane, so it's going to be a little hard. Well, maybe I should just choose the one that it would be perpendicular to. Not the right plane, but the top plane instead. There we go. It's perpendicular to that top plane, going through that point, and that's the point and face plane. Okay, now that I've got my axis, the rest of this is easy. I'm going to make a revolved cut, not an extruded cut, a revolved cut. And I'm going to make sure I use that front plane, that internal middle plane, to do my sketch. And now you can see the outline. I'm going to try not to associate it with that point that I have right there, because that point is on the far plane over here, not on the middle plane. So let's sketch out in space here. I'm going to go all the way to the axis. And I did that to make a closed loop so that the computer knew exactly what I was trying to cut out. I'll make dimensions. Go from the bottom up because I made them a little bit small. So there we go. It's looking a little better. Now I need to make the radial dimensions. This is the 4.5. Uh-oh, what happened over here? It looks like I did not make this collinear with the axis. That's kind of crucial. So I'm going to go back and make sure that that relationship is intact. And I'm going to get rid of this dimension here. It's having a problem. Try this again. Dimension from here to here, right now, here to here, 4.69, from here to here. Okay, now we are ready to cut. With one exception, we should make a center line coincide with this one so that it knows which line to rotate it on. Not always necessary, but I have to make sure it's there. It already assumed that line 11 was the rotational axis, so it's going to take that outline and rotate it about this axis and cut everything in its path. And there is our cut. Notice how it follows right through that point at that right there, but it is not a straight cut, it is a curve, and the best way to do it is this revolved cut. Could you cut down from the top with these curves? Absolutely, but then you would need to do 1, 2, 3 separate cuts instead of one cut that made a lot of sense with respect to the actual use of this part. It makes sense to make this axis anyway because it will be assembled with other parts that will use the same axis. Now, last but not least, we need to make 2 holes. We will use the Hole Wzard for this, and it will have a simple counterbore, but notice that it will be on 2 levels, this level and this level. So it comes in as inch, and we've got custom sizing all ready to go here, and it is given that we have a through hole of 1/2 inch and counterbore diameter 3/4 of an inch, and that counterbore goes in 810 thousandths. And now we need to know its positions. Because it's on 2 different levels that we're going to place this, we want to use 3D sketch. Now, one more thing I caution is not to place those points too close to where you actually want them. You want to place them on that surface and then move them to the right locations. Not as crucial here, but it can cause problems in other places. So I'm going to put one here and one here. Now we want to escape out of making points, and we want to align these points on to the front plane. Click on plane. Same thing with this one. Hold the control key, click on front plane, and relation will be on plane. Now all we need to do is dimension them from the front plane. Now that we're in 3D Sketch, the dimensioning scheme's a little bit funkier. We need to make sure that we choose off the plane to that point. And then 0.75. And we try to go from this point to this point, it will only give us this slanted situation. We won't be able to change that. So we can't do it exactly as the drawing tells us to. But we could make a center line that goes from this point down. And then we can make our dimension from that line to that point. And make it 5 as shown on the diagram. And now we're all set. Now notice how this hole does just barely graze this surface, but that's definitely the surface that this is intended to be on. So here is our final chuck jaw. Notice how it only took 4 major features and 2 minor features, or at least a feature and a sketch. We were able to complete this complex geometry here and let it be reflective of the design intent, as there's an axis here that all the other parts will have to go around, and we'll want to be able to reference this and assemble them in that kind of fashion. So we were able to capture design intent and create this somewhat complex geometry in one revolved cut. We also used 3D Sketch to create these 2 holes, and the usual extruded boss, base, and cuts for the other 2 features.